This Bodum coffee frother has a design flaw that allows it to keep turning itself on all day long while you're at work. It will heat up any milk that's left over inside the container, burn it, make it smoke, and possibly set off your smoke detectors, or even worse.
Last week, our coffee frother stopped working after only 9 months. The heating element quit heating even though it would stir, and I said I'm tired of spending $40 on coffee frothers that last less than a year, so I looked for a less expensive alternative. I got this one by Bodum. It was only $26. Unlike the other ones which I had, which have like 4 modes, all kinds of different hot and cold options, this just has one thing it does. A toggle switch, on and off, and it froths coffee, and it does a terrific job. Inside it has a circular whisk that's held on by a magnetic attachment, so you can take it out and it's really easy to clean because you can get the sponge in there without bumping into the whisk or bending it, and then it snaps right back on. So I really like what this thing does, and I really like the simplicity of the single switch. Unfortunately, in the process of testing it out in the first week, I found what I consider to be a legitimate design flaw. This flaw is either going to cause it to wear out about 10 times faster than it should, shortening its lifespan, or in the wrong circumstances, I really believe that the flaw could lead to a fire. So I'm not just going to complain about this device, I tested it. I put it up with the thermocouple and a multimeter and a time-lapse clock to show you how this can actually lead to having the device come on while you're not home all day long. I think it's a bit hazardous the way it's designed. So I want to show you what that problem is, and when I'm done, you can decide for yourself. Maybe you'll say this is a great inexpensive alternative to the more fancy frothers, and you're going to say, I can handle that design flaw and work around it. Or you're going to say, that's awful, and the manufacturer needs to do something about that before it releases the next generation. Let's have a look at what's going on. So to start with, let's just see how it works. I throw milk into it up to the fill line, hit the toggle switch, and it does a great job. It doesn't splash out, the milk gets hot really fast, it's terrific. Now fast forward to the moment when it shuts off. In real time, that took about 1 minute and 15 seconds. Now, one of the interesting things about this switch is the thermal fuse has just disabled the front power switch. Nothing I do here can change it. This is interesting because I can't make the thing froth again. Like if I decide I want to add some chocolate to it or anything like that, too bad, it's disabled itself until it cools off. So with the power switch still in the on position, I'm going to walk away. So take the frothed milk out. 14 minutes later, the thermal switch cools off, the analog switch is still in the same position, and the frother kicks back on and begins to heat the same milk all over again. When it reaches the shutoff temperature again, it turns off, but you can see now the milk is bubbling and steaming. Now the thermal switch starts to cool again, and as soon as it's done, the frother will turn back on again just about every 10 to 15 minutes all day long. After a couple more cycles, it's starting to burn the milk in the bottom of the cup, and it'll just keep doing this all day long. I set the frother up with a clock so we can heat some milk and see how long it takes it to come back on again. I've got my multimeter here set on Fahrenheit degrees with a K-type thermocouple. I'm using a K-type thermocouple, and I have some Kapton tape. This is high temperature tape that has an adhesive that doesn't get gummy when it's warmed up. So I'm going to tape the thermocouple onto the inside of the frother. I'm placing it at a height where it will be fully immersed in the milk, but not touching the hot bottom surface where the heating element is, right underneath the thermocouple's tip. We're starting out at 67 degrees, which is about the ambient temperature. I set the clock to an even hour to more easily keep track of the amount of time that passes, and I'm going to speed the video up really fast.
But first, let's load it with something to froth. This is straight out of my fridge. You can see it's about 40 degrees Fahrenheit. I'm using eggnog in this case instead of milk. I've got the unit plugged in, so let's start it up. I'm going to speed the video way up so that you don't have to watch while all this happens. So let's go to 8x. You can see the temperature climbing up to the point where it automatically shuts off. So here it comes. The unit just shut off at about 124 degrees Fahrenheit. You can see it immediately begins to start cooling, and the power button LED goes off, but the switch is still switched to the left. The problem is that analog switch doesn't have a digital override to tell it not to come on again. So as soon as the thermometer inside drops to the set temperature, it's going to start up again and begin frothing all over. So let's see how long that takes. Keep an eye on the clock on the left, and I'm going to speed everything up to 100x. It kicked on. The temperature dropped to about 103 to 104 degrees, and the machine automatically turned itself back on and began frothing the same load of eggnog. It'll keep on doing this all day. I'm going to let it heat up, turn itself off, and then cool down again and see if it keeps on triggering. The thermostat tripped again at about 127 degrees, so let's fast forward through time and see how long it takes it to have the thermostat reactivate the analog switch. Okay, the temperature's fallen to 104, and there goes the unit. It just turned itself back on for the second time without ever being touched. So now the temperature's rising, and it's going to keep doing this all day until the eggnog is completely steamed off and begins to burn. You see there it shut off at about 128 degrees again. So I thought surely if I disconnect the frother from the power by taking it off the base and use the milk that I frothed and put it back, it's not going to continue running all day long after I've disconnected it and reconnected it. So the switch is still flipped into the on position. It's never been moved. And now I'm going to let it cool down below the thermostat switch temperature and see if it kicks on again after having been disconnected from the base. We'll fast forward at 100x. And as soon as the temperature gets down to 96, it starts right back up again with an empty bowl. Now it's going to heat nothing but the thin layer of milk at the bottom and begin to boil and burn it. There you can see it got to 208 degrees this time before it shut off, with nothing inside to absorb the heat. So the temperature is slowly dropping. The frother is still connected to power, and the milk at the bottom is still cooking at 180 degrees. It's blistered and bubbling and begin to caramelize. So I'll leave it on here for one more cycle. The switch is still on the left-hand side. The temperature's dropped to 170 and it's going to fall to the point where it kicks on again. And there it goes, reliably at 95 degrees. So now it's heating up the same thin layer of milk that it was before. We'll speed through the heating, but if you listen closely, you can hear it boiling. All the solids in the milk and the sugar in the eggnog are now burned onto the bottom of the frother. And this cycle will just keep repeating. I let the unit cool down to ambient temperature and I washed the inside. I can put back in the whisk now, which is really easy to remove, bonus for this unit. And you can see that the temperature's dropped down to about 65 degrees Fahrenheit. Throughout this test, I never moved the power switch. I put it in the on position when I started, and it's been there throughout the test. So now after all this, I just want to place it right back on the base after it's cooled down, and we see that it immediately starts up again. Anytime the thermometer has dropped below the reset temperature and the switch is in the on position, this unit comes on. You can see now it's heating with a completely empty container. Then when it reaches the shutoff temperature, it clicks off at around 112 degrees, but the temperature of the thermocouple, which is at the base of the cup right now, continues to rise. Even though it doesn't have any more power, the bottom of the cup is getting hotter and hotter. So this is actually a pretty good frother. If you get up each day with your switch turned off on the frother, set it on the base, add your milk, and turn the switch on. You let it heat up, froth your milk, and as soon as it's hot enough, you take it back off, add it to your coffee, and wash it. When you come back, turn the switch off, and you can set it back on your base. But if you leave the analog power switch turned on after you've washed it and put it back on your base, it's immediately going to power up. But if you put it back while the insides are still above 96 degrees, it's not going to come on until it cools down after you've walked away. And you just don't want something that gets this hot turning itself on and off in your home when you're gone. Well, I hope that gave you enough information to use this frother safely if you decide to purchase it. Thanks for watching.